Inside a modern industrial factory, tons of freshly harvested cassava roots arrive every single day. These thick, starchy roots may look simple from the outside, but they are the foundation of a revolutionary fabric used to make comfortable, breathable, and eco-friendly clothing. The entire process combines agriculture, chemistry, and textile engineering into one seamless production line. The process begins with raw cassava reception and inspection. Trucks unload massive quantities of cassava roots onto conveyor belts. Skilled workers and automated scanners inspect the roots to remove stones, damaged pieces, and impurities. Only high-quality cassava is allowed to move forward, ensuring a consistent and premium final fabric. Next comes the washing and peeling stage. The cassava roots pass through rotating washing drums filled with clean water, removing soil and debris.
Pressure stable at
High-pressure water jets
2.1
clean
bar.
every surface thoroughly.
Confirmed.
After
Flow
washing,
rate is
automated
optimal.
peeling machines
Check the
remove the
temperature
thick brown outer
gradient.
skin,
Gradient is
revealing the
within
white,
spec.
starchy interior. Cleanliness at this stage is critical for producing pure fibers later. The peeled cassava is then sent to the crushing and grinding section. Powerful industrial grinders break the roots into a fine pulp. During this process, water is added to help release the natural starch locked inside the cassava cells. The factory floor vibrates slightly as heavy machinery works continuously, transforming solid roots into a smooth, milky slurry. After grinding, the mixture moves to the starch extraction system. Using filtration screens and centrifugal separators, the liquid starch is separated from the fibrous residue. The fibers are removed, while the starch-rich liquid is collected in large stainless steel tanks. This extracted starch is the heart of cassava-based textile production. The collected starch then undergoes purification and refinement. It is washed multiple times to remove any remaining impurities. Temperature and pH levels are carefully controlled to maintain starch quality. Once purified, the starch appears bright white and smooth, signaling it is ready for conversion into textile material. In the chemical modification stage, the cassava starch is transformed into a usable polymer. Through a controlled reaction process, the starch molecules are altered to improve strength, flexibility, and durability. This step turns natural starch into a fiber-forming material similar to synthetic textiles but with a plant-based origin. Next, the modified starch enters the fiber spinning process. The liquid polymer is pushed through spinnerets with extremely fine holes, forming long, continuous filaments. As these filaments cool and solidify, they become strong cassava-based fibers. Airflow and temperature are carefully adjusted to ensure uniform thickness and smooth texture. Once formed, the fibers are stretched and strengthened. Stretching aligns the molecular structure, increasing tensile strength and elasticity. This makes the fibers suitable for daily wear clothing that needs to withstand repeated use and washing. The strengthened fibers are then sent to the weaving and knitting department. High-speed textile machines convert the fibers into fabrics using various patterns, depending on the intended use. Some fabrics are woven tightly for durability, while others are knitted loosely for softness and breathability. After weaving, the fabric moves to the finishing and treatment section. Here, the fabric is washed, heat-set, and treated to improve softness, color absorption, and resistance to wrinkles. Eco-friendly dyes may be applied, giving the fabric vibrant colors suitable for fashion and everyday apparel. Finally, the finished cassava fabric undergoes quality control and packaging. Technicians check fabric strength, texture, color consistency, and comfort. Once approved, the fabric is rolled, packed, and prepared for shipment to clothing manufacturers around the world. From humble cassava roots to premium wearable fabric, this factory process showcases how natural resources and modern technology come together to create sustainable textiles for everyday life. Inside a vast industrial complex, the transformation of ordinary cassava roots into high-quality fabric begins long before a single thread is formed. Every day, tons of freshly harvested cassava arrive at the
Pressure
factory,
stable at
delivered from
2.1
farms where the
bar.
crop has been grown
Confirmed.
specifically
Flow
for
rate is
industrial textile
optimal.
use.
Check the
These
temperature
roots,
gradient.
rich in natural
Gradient is
starch,
within
are the
spec.
key ingredient behind a new generation of sustainable fabrics used in everyday clothing. The process starts at the raw material intake zone. Long trucks unload mountains of cassava onto wide conveyor belts that stretch across the factory floor. At this stage, quality control is already in action. Workers and automated vision systems inspect the roots, removing stones, soil clumps, and damaged or rotten cassava. This careful selection ensures that only clean, mature roots move forward, because the quality of the starch directly affects the quality of the final fabric. Once approved, the cassava enters the industrial washing system. Huge rotating drums filled with fresh water tumble the roots continuously. High-pressure water jets blast away every trace of dirt trapped in crevices. Clean cassava is essential, as even small impurities can interfere with later chemical processes. After washing, the roots move into automated peeling machines, where sharp mechanical blades remove the thick brown skin, exposing the bright white interior packed with starch. The peeled cassava then flows into the crushing and pulping section, where heavy-duty grinders reduce the solid roots into a soft, wet pulp. Water is added during grinding to release the starch from the plant cells. The sound of machines is constant and rhythmic, as tons of cassava are processed without stopping. What was once a solid root now becomes a smooth, milky mixture moving steadily through pipes.
Aligned.
This mixture is directed to the starch separation and extraction system.
Looks clear.
Using fine filtration screens and high-speed centrifugal separators, the factory separates starch from leftover fibers. The fibrous waste is collected for reuse in animal feed or bioenergy production, ensuring nothing goes to waste. The starch-rich liquid, now purified of solids, is stored in massive stainless steel tanks. Next comes starch refinement and purification. The starch solution is washed repeatedly and carefully monitored for temperature, pH balance, and purity. Any remaining impurities are removed at this stage. The result is ultra-clean cassava starch with a bright white appearance and uniform consistency. This refined starch is no longer food grade, it is now ready for industrial transformation. The refined starch enters the chemical conversion phase, where science turns natural material into textile-grade polymer. Through controlled chemical reactions, the starch molecules are modified to increase flexibility, durability, and resistance to moisture. This step is crucial because raw starch alone cannot be spun into strong fibers. The factory carefully controls reaction time, pressure, and temperature to achieve consistent results. After modification, the liquid polymer moves to the fiber spinning department, the heart of the fabric making process. The polymer solution is forced through precision spinnerets containing thousands of microscopic holes. As the liquid exits these holes, it forms long, continuous filaments.
This line is perfectly
Cooling air
aligned.
solidifies the strands almost instantly,
Let's check
turning
the next
liquid
section.
polymer into
Looks
solid
clear.
cassava-based fibers.
Proceed.
These newly formed fibers then undergo stretching and alignment. Stretching aligns the internal molecular chains, dramatically improving strength, elasticity, and durability. This process ensures the fibers can withstand daily wear, washing, and repeated movement without breaking or losing shape. The strengthened fibers are wound onto large spools and transported to the textile production hall, where weaving and knitting machines operate around the clock. Depending on the intended fabric type, fibers are woven tightly for durable clothing or knitted loosely for softness and breathability. Advanced machines work at incredible speeds, transforming thousands of meters of fiber into smooth fabric sheets. Once woven, the fabric enters the finishing and enhancement stage. It is washed, heat-treated, and softened to improve comfort against the skin. Eco-friendly dyes are applied when color is required, allowing the fabric to absorb vibrant shades evenly. Additional treatments may be added to enhance wrinkle resistance, moisture control, or breathability, making the fabric suitable for everyday wear. Finally, the fabric reaches quality inspection and packaging. Skilled technicians examine texture, tensile strength, color consistency, and overall feel. Only fabric that meets strict standards is approved. The finished material is rolled, labeled, and packaged, ready to be shipped to clothing manufacturers around the world.
Pressure stable at
cassava roots to
2.1
premium
bar.
wearable fabric, this
Confirmed.
factory
Flow rate
process
is
demonstrates
optimal.
how nature and
Check the
technology work
temperature
together to
gradient.
create
Gradient
sustainable
is within
textiles for
spec.
modern life. What starts as a humble root ends as a fabric worn daily by millions, proving that the future of clothing can be both innovative and environmentally responsible. At first glance, cassava looks like nothing more than a rough, muddy root pulled from the earth. It is heavy, uneven, and completely unremarkable. Yet inside a massive industrial factory, this humble crop becomes the foundation of a modern textile revolution. Every single day, thousands of tons of cassava enter this facility, beginning a journey that transforms natural starch into premium fabric worn by people around the world. The process begins far outside the factory walls, in vast agricultural regions where cassava is cultivated specifically for industrial use. Once harvested, the roots are transported quickly to prevent degradation. Time is critical, because fresh cassava contains the highest quality starch. As trucks arrive at the factory gates, the scale of the operation becomes clear. Conveyor systems stretch for hundreds of meters, designed to handle enormous volumes without interruption. Inside the raw material receiving zone, cassava is unloaded and spread across wide moving belts. Here, quality control begins immediately. Advanced optical scanners examine each root, identifying size, density, and surface defects. Human inspectors assist by removing stones, damaged roots, or foreign materials. This careful screening ensures that only cassava with optimal starch content continues into production. The approved roots move into the industrial washing section, where cleanliness becomes the top priority. Giant rotating drums filled with continuously refreshed water scrub the cassava from every angle. High-pressure jets remove soil trapped in cracks and crevices. The water system is filtered and recycled to reduce waste, reflecting the factory's commitment to sustainability. After washing, the cassava enters automated peeling machines. These machines remove the thick, dark outer skin with precision blades, exposing the bright white interior. This inner core is where the valuable starch is stored. Any remaining peel fragments are removed automatically, ensuring uniform purity. The peeled cassava flows directly into the crushing and pulping department. Here, powerful grinders break the roots down into a fine pulp. Water is added to assist in releasing starch from plant cells. The atmosphere is filled with the steady hum
Pressure
of industrial
stable
motors,
at 2.1
as tons of cassava
bar.
are reduced into a
Confirmed.
smooth,
Flow
milky
rate
slurry
is
within
optimal.
minutes.
Check the
This slurry
temperature
is pumped
gradient.
into the starch
Gradient
extraction
is within
system,
spec.
one of the most critical stages in the entire process. Using layered filtration screens and high-speed centrifuges, the factory separates starch from fibrous material. The heavier starch particles settle and are collected, while lighter fibers are removed. These leftover fibers are not wasted. They are redirected for use in animal feed, compost, or bioenergy production. The extracted starch then enters large refinement tanks, where purity is perfected. Multiple washing cycles remove trace impurities. Temperature, acidity, and consistency are monitored by automated sensors. At this stage, the starch reaches an ultra-clean, uniform quality suitable for industrial modification. Now the transformation becomes scientific. In the polymer conversion section, the refined cassava starch undergoes controlled chemical reactions. Natural starch molecules are altered to create a flexible, durable polymer capable of forming fibers. This step bridges agriculture and textile engineering, turning a food-based material into a fiber-ready substance. The modified polymer solution is transferred to the fiber spinning hall, the heart of fabric production. Precision spinnerets force the liquid polymer through thousands of microscopic openings. As it exits, it forms endless thin filaments. Cool air solidifies the strands instantly, locking in strength and smoothness. These fresh fibers are then stretched and aligned. Stretching reorganizes the molecular structure, increasing tensile strength and elasticity. This ensures the fibers will not tear easily and can endure daily wear. The fibers are then wound onto massive spools, each holding kilometers of continuous thread. From here, the process enters the textile manufacturing zone.
This line
Weaving
is
and knitting machines
perfectly
operate
aligned.
at extraordinary
Good.
speeds, interlacing
Let's check the
cassava-based
next
fibers
section.
into fabric sheets.
Looks clear.
Different techniques
Proceed.
create different textures. Tight weaves produce durable materials for everyday clothing, while looser knits create soft, breathable fabrics ideal for comfort wear. Once fabric is formed, it moves to the finishing department, where raw textile becomes wearable material. The fabric is washed to remove processing residues, heat set to stabilize shape, and soften for skin comfort. Eco-friendly dyes may be applied, allowing deep color penetration without harming fiber integrity. Additional treatments improve moisture control, wrinkle resistance, and durability. Finally, the finished fabric reaches quality assurance. Technicians test strength, flexibility, breathability, and color consistency. Only material that meets strict standards is approved. The fabric is rolled, labeled, and packaged, ready for shipment to clothing manufacturers worldwide. From soil-covered cassava roots to smooth, wearable fabric, this factory process reveals how innovation and sustainability come together. What once fed communities now also clothes them, proving that the future of textiles can grow directly from the earth.